everyone, welcome to our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your physics class 11 part 1, which has been the NCERT we have to discuss here. And in the same phase, this has been the classes your class 6 we had completed in the last classes, which has been the unit 1, and into this class we have to start discussing about unit 2, which has been the units and measurement. In unit 1 we had done that, and we start with, before starting with this unit 2, which has been the units and measurement, we have to start with the questions that has been asked in your unit 1, that is being for NCERT. And but before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that me and maximum people can get the information at once, and you can also enjoy the video as well. So for the unit 1, that we have your questions here has been the question is, first question is, some of the most profound statements on the nature of the science have come from Albert Einstein, one of the greatest scientists of all the time. And what do you think that the Einstein mean when he said the most incomprehensible thing about the world is that it is compressible? Now the second question is your, every great physical theory starts as a heresy and ends with a dogma. Give some example from the history of the science of the validity of its incisive remark. The third question, politics is the art of the possible. Similarly, science is the art of soluble. Explain this beautiful aphorism of the nature, practice of science as well. The fourth question for the same is your, that is, though India now has a large base in science and technology, which is fast expanding, and it is still a long way for realizing its potentials of becoming a world leader in science. Name some important factors which in your view have hindered the advancement of science in India. The fifth question is, no physicists have ever seen an electron, yet all physicists believe in the existence of electron. An intelligent but a superstition man advances this analogy to argue that ghosts exist even though no one has sees one. How will you refute this argument? The sixth question is that the shell of a crabs found around a particular coastal locations in Japan that seem mostly to be resemble the legacy phase of the samurai, and give below are the two explanation of the above observed fact, which of these strikes you as a scientific explanation. So the first statement we have that a tragic sea accident several centuries ago downed a young samurai, and as a tribute to his bravery, nature, though it is inscrutable way, immortalized his face by imprinting it on the crab shell in that area. The second statement is after the sea tragedy, fishermen in that area, in a gestures of honor of their dead heroes, let free any crab shell and caught by them which accidentally has a shape resembling the face of samurai. Consequently, the particular shape of the crab shell survived longer, and therefore in course of time the shape was genetically propagated, and this is an example of evolutions of artificial selection as well. So where the interesting allusions takes from Carl Sagan's The Cosmo highlights that the fact that is often the strange and inexplicable fact which on the first sight appears supernatural actually turn out to have a simple scientific explanation, and you have to try to think out the other examples of this kind as well. So we go for the same here. So next we go for the next question. Has been seventh question of the unit 1, and that the industrial revolutions in England and Western Europe that more than 2 centuries ago was triggered by some key scientific and technological advances. What were these advances as well? Then going ahead with eighth question, and that is being, it is often said that the world is witnessing now a second industrial revolution which will transform the society as radically as it did the first, and list some key contemporary areas of science and technology which are responsible for this revolution as well. We'll go for the ninth question. Has been write in about 1000 words a fiction piece that is based on your speculations on the science and technology of the 22nd century. Now if you go for the 10th question, is to attempt to formulate your moral views on the practice of science. Imagine yourself stumbling upon a discovery which has a great academic interest but is certain to have nothing but dangerous consequences for the human society. How, if at all, will you resolve your dilemma? 11th question of the session is to be science like any knowledge that can put to good or bad use depending on the user. Given below are the sum of the applications of science that formulate your views on whether the particular application is good, bad, or something that cannot be so clearly categorized. The first, that mass vaccination against smallpox to curb and finally eradicate these diseases from the population. This has been already been successfully done in India. And another is to television for eradication of filter illiteracy and for mass communication of new that and ideas, news and ideas. Third is prenatal sex determination. The next is the computer for increase in work efficiency. Next is putting artificial satellite in orbits into the orbits around the earth. Another is your development of nuclear weapons. Next is your development of new and powerful technique of the chemical and biological warfare. And that is purifications of water for drinking. Another is plastic surgery, and then next is your cloning here. Next we talk about for the 12th question of the sessions as well, which has been India has been a long and unbroken traditions of the great scholarship in mathematics, astronomy, and of course linguistic, logic, and ethics as well. Yet, in parallel with this, several superstitious and obscurantistic attitudes that has a practice flourished in our society and unfortunately continue even today among many educated people too. How will you use all your knowledge of science to develop the strategies to counter these attitudes as well? The 13th one is, though the law gives a woman equals to the status in India, many people hold unscientific views on the woman's innate nature, capacity, and intelligence, and in practice that gives them a secondary status and role that demolish this view using the scientific argument and by quoting that example by a great woman in science and other spheres, and that persuade yourself and the others that give equal opportunity. Women are on par with men here. Another is your 14th question, we talk about it, which is, it is more important to have a beauty in the equations of physics than to have an agree with experiment. And the great British physicist PAM that Dirac held this view and criticized the statement alleged some of the equation that results in the book which can strike you as a beautiful. Now another 15th question is, though the statement quoted above may be disputed, and most physicists do have a feeling that the great laws of physics are at once simple and beautiful. Some of the notable physicists beside Dirac who have articulated this feeling, and that are Einstein, Bohr, Heisenberg, Chandrasekhar, and Feynman, and you are urged to have a special efforts to get access to the general books and writing by the other great masters of physics. Her writings are truly inspiring. Another we talk about for The next question has been the 16th question of unit 1 of the session, which has been the textbooks on the scientific that may give you a wrong impression that studying the science is a dry and are all too serious, and that scientists are absent-minded introverts who never laugh or grin. That is the image of the science and scientists is patiently false. Scientists, like any other group of human that have their shares of humorist, and many have led their lives with a great sense of fun and adventure, even as they seriously pursued these scientific work as well. And two great physicists of the genre are Gamow and Feynman. You will enjoy reading their books listed in the bibliography as well. Now we talk about for the unit 2, which has been the units and measurement, that we should continue here. So on the same behalf of it, that has been the in units and measurement, we first discuss about the introduction. What is all about your units and measurement? Okay, so for the introduction here, about units and measurement, we discuss about the measurements of any physical quantity that involve that compromised with a certain basic arbitrary chosen internationally accepted reference standard called unit. The results of measurement of the physical quantity is expressed as by the number of numerical measure, and that accompanied by a unit. Although the numbers of physical quantities that appear to be very large, we need only a limited numbers of units for expressing all the physical quantities as well. Since they are interrelated with one another, the units for the fundamentals or the base quantities that are called fundamentals or base unit. The units of all other physical quantities that can be expressed as combinations of the base unit. Such units obtained for the derived quantities that are called derived units, and a complete which has been the set of these units, both the base units and the derived units, it is known as a system of units as well. Now we talk about the international systems that of so the international system. The international systems here, in earlier time the scientists of different countries were using different systems of using for units of for measurement. Three such systems, that is CGS, FPS or British that system, and of course the MKS systems that were in the use of extremely extensively till recently. So the base units for the length, mass and the time in the system were to be as follows. I will just write it down for you all so that you will get to know about it in detail. So the base units for length, the base units for length, mass and time in these systems were as follows. So for the same, talking about the first one, in CGS system there were centimeters, gram and second respectively. In CGS system they were centimeter, gram and second respectively. In FPS system they were foot, pound and second respectively. Another is your in MKS system They were meter, kilogram, and second, respectively. On the same behalf of it, that the systems of the unit, which is at present internationally accepted for a measurement in the Système International d'Units, which is in French for the International Systems of Unit, that is abbreviated as SI as well. The SI that with the standard schemes of symbols that has been abbreviated as SI, and with the standard scheme of the symbols, units and abbreviations, was developed and recommended by the General Conference on Weights and Measures in 1971 here. That has been in 1971 for international usage in scientific, technical, industrial and commercial work here, that we have to discuss about it, because SI units that use decimal systems conversions within the system that are quite simple and convenient. We shall follow that has been that SI units are at the in this book we'll discuss about it. So in SI there will be 7 base units as given in the further table. We talk about for the SI base quantities and units as well, that besides 7 base units, these are the 2 more units that has been divided for a plane here, and of course for the plane angle d theta, that is and the ratio of the length of the arc ds to the radius r. The second talk about solid angle, that is d, we have as a ratio of that is intercepted area dA of the spherical surface, and that is being described about the apex here at the center, and to the square of its radius r, and we are in the same discuss about it. The units of the plane angle is radian with the symbol rad, and the unit for the solid angle is the steradian, and which has been the symbol of SR. Both these are the dimensionless quantities as well. So we talk about for the same here. So we go for SI based units, quantities and units as well. Of course, that is being important one. So here we go. SI base quantities and units. So first we talk about the base quantity. Then again we have your SI units. So for the same it will be your name. Then we have your symbol, and then we talk about for the definition as well. So here we go. This is we have. So with the same, we go for that. The values that mentions there are needed not to be remembered as an ask in the test, but they are given as here for that only to indicate that the extent of accuracy to what they be are measured, and with the progress in technology, and that a measuring technique that get improved, leading to the measurements with greater precisions, and that the definitions of the base unit that are revised to keep up with this progress as well. So we go for the same. The base quantity we have first has been the length, and the name is of course the meter. The symbol is this meter, and the small m. The definition for the same is your, which has been that the meter is the length of the path that traveled by a light in a vacuum, that during a time interval of 1 by that I will just write it down for you. The meter is the length of the path traveled by light in vacuum during a time interval 1/299,792 and then 458 of a second. In 1983 it will be. Okay, now we talk for another one. It has been 1983. Now talking about for another base quantity has been mass. Then the name is your kilogram. The symbol is kg. The definition is that the kilogram is equals to the mass of the international prototype of a kilogram, whereas a platinum iridium alloy cylinder it kept at International Bureau of Weight and Measures at Sèvres near Paris, that is France, in 1889. The kilogram is equal to the mass of the international prototype of the kilogram a platinum iridium alloy cylinder kept at International Bureau of Weight and Measure at Sèvres near Paris, France, which is in 1889. Now talk about for the base quantity. Then the base quantity is being your time. Then for the same it will be your second. Symbol is S. For this it is be that the second is the durations of we have the second is the duration of 91926311770 periods of the radiation corresponding to the transition between two hyperfine levels of the ground state of the cesium 133 atom, which is in 1967. Now we talk about for the another one, which is for electric current. For electric current, and for the same electric current we talk about it will be your that has been ampere. and which is being representing by A. So here that the ampere is that constant current, the ampere is that constant current which is maintained in two straight parallel conductors of infinite length. So for the same it will be that infinite length and of negligible circular cross section of negligible, that is being of negligible circular cross section and placed 1 meter apart in vacuum. That would produce between these conductor a force equals to 2 into 10 to the power minus 7 Newton per meter of length, which is in from 1948 here. That has been which we have to discuss as well, and now we'll be going to end up here only, and we'll continue with the next coming class the rest of the basic quantities, names, symbols and definitions as well, and which is from your that is in the thermodynamic temperature as well. So but before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So other than physics, we talk about, we had done your sociology and software engineering, even though we had done your sociology and your chemistry for class 11th part 1, and chemistry for class 12th part 1, which has been the unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9, with their logarithms and antilogs as well, the conversions as well. We had started with chemistry for class 11th part 2, which is about, we had started with redox reaction that we have to cover up. Other than this, we had done your reasoning, wherein that we had done verbal reasoning in general mental ability, and the logic reasoning. In non-verbal reasoning we had done your series analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, role situation, constructions of squares and triangles, figure formation, analysis and practice question set as well. In the same phase we had started with quantitative aptitude. In that, so where in that quantitative aptitude we had done started with arithmetical ability. In that we had done operations on numbers, SCF and LCF of numbers, decimal fractions, simplification, square roots and cube roots, problems on numbers, problems on ages, surds and indices, percentage, profit and loss, and ratio and proportion, and many more we have to cover up here as well. We had done your ER diagram, we have been dealing with English vocabulary, we are dealing with PHP interview questions, and this many more we have to discuss here. So on the same behalf of it, coming towards physics, which has been the part 1 for class 11th, which we had started with. Here in that we had started with even though we had ended up with, which has been the chapter unit 1, which has been the physical world, which we have to discuss here. In that we have to do with what is physics, scope and excitement of physics, physics technology and society, fundamental forces in nature, nature of physical laws as well. Unit 2, which we had started, that has been the units and measurement. It has been the introduction, the international system of unit, measurement of length, measurement of mass, measurement of time, accuracy, precision and instrument, and the errors of measurement as well. In terms of it, significant figures, dimensions of physical quantity, dimensions formula, and a dimensional equation, dimension analysis and application as well. In terms of unit 3, which has been, you have to cover up the motions in a straight line, which has been introduction, position, path, length and displacement we have to cover up, average velocity and average speed, instantaneous velocity and speed, acceleration, kinematics, equations for uniformly accelerated motion as well, in terms of relative velocity as well. In the same phase we talk about it, which has been unit 4, is your motion in a plane, which we have to cover up the introduction, scalars and vectors, multiplication of a vector by a real number, addition and subtractions of a vector, graphical method, and resolutions of vector as well. In the same phase, if I'm talking about with a continuing of this unit is here, which has been the vector additions, analytical method, motion in a plane, which we have to discuss here. And on the same phase is that is your motion in a plane with a constant acceleration, relative velocity in a 2 dimensions, projectile motion, and uniform circular motion as well. On the same behalf of it, we have to discuss many more here, which has been the unit 5th, which has been the law of motion, and that in that we have to cover up the introduction, Aristotelian fallacy, the law of inertia, Newton first law of motion, Newton second law of motion, Newton's third law of motion, conservations of momentum that we have to cover up, which has been the conservation of momentum or equilibrium of particles, common forces in mechanics, circular motion, solving problems in mechanics. In unit 6, which we have to cover up, has been your work, energy and power. In that we have to cover up introduction, notions of work and kinetic energy, the work energy theorem, work, kinetic energy, work done by a variable forces, the work energy theorem for a variable forces, the concept of potential energy, the conservation of mechanical energy, the potential of a spring as well, various forms of energy, the law of the conservation of energy, power and collision as well. On the same phase we talk about it further. Another one here has been, in terms of it, that is in your chapter 7, we have to cover up the system of a particle and rotational motion here. That we have to cover up here is your introduction, center of mass, motion of a center of mass, linear momentum of a system of particles, vector product of the two factors, angular velocity and its relation with the linear velocity, with the same torque and angular momentum and equilibrium of a rigid body, moment of inertia, theorem of perpendicular and a parallel axis as well, with kinematics and the rotational motions about the fixed axis, dynamics of rotational motions about the fixed axis, angular momentum in the case of the rotation about the fixed axis, and rolling motion as well. On the same figure we talk about further another one, which is being for unit 8, that has been the gravitation. Here we have to cover up, the introduction, Kepler's law, your first law of gravitation, the gravitation constant, acceleration due to the gravity of the earth, acceleration to the gravity of below, and the above surface of gravitational potential energy, escape speed or the satellite energy of the orbiting satellite, geostationary in a polar satellite, and weightlessness as well. So we're gonna end up with, and here we continue with the next coming class that we have to discuss here. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.